All right, here we are. Question number one. Let the fun begin. And question number one asks us to solve the equation by the zero factor property. And we've been given the quadratic equation 3x squared minus 5x minus 8 equals 0. And so if we're told to solve this equation by the zero factor property, what they want us to do is factor the left-hand side of this equation. And once we have this equation, the left-hand side, in factored form, we're going to set each of our factors independently to 0 and then solve. So let's go ahead and do that now. When it comes to factoring the left-hand side here, there are a number of different ways and methods that we can use to factor. So we can use trial and error method, we can use the scissors method, we can use the AC method. And I'm going to go ahead and use the AC method, I think, here for number one. So the AC method, hopefully that sounds familiar from class. And what this method tells us to do is take the coefficient of the square term, so in this case 3, and multiply it by the constant here at the end, in this case 8. So when we multiply these two numbers together, we're going to get 24. And now we want to list all of the factors of 24. Well, we have 1 times 24, we have 2 times 12, we have 3 times 8, and I think our last one will be 4 times 6, right? All right, so now that we have all of our factors of 24, what we want to do is we want to take a look at these factors and say to ourselves or ask ourselves, using these factors, is there a way that I can use subtraction, because this last sign here on the left hand side is a minus, so using subtraction, is there some combination I can get a -5 with these factors? Well, let's see. Well, 1 minus, right, our last sign is subtraction, so minus. 1 minus 24 does not give us -5. And if we switched it around and we did 24 minus 1, well, that's still not -5. So we can go ahead and exclude the factors 1 and 24. How about 2 and 12? Well, let's see. 2 minus 12, again, not -5. That's what we're looking for. 12 minus 2, again, not -5. So we could try several different combinations. Still no way we're going to be able to get -5. But if we, look at this, 3 and 8, we can probably get a -5, right? Well, let's see. What do the signs of each of these numbers have to be? Well, if we make 3 a positive and we make the 8 a negative, +3 minus, right, subtraction, 8 does indeed give us a -5, which is what we're looking for. So we know we're going to go ahead and use the 3 and the 8, and based on our quick little arithmetic here, we know that we're going to assign the 3 a positive sign, a plus sign, and we're going to assign the 8 a minus sign. All right, and we could keep going and take a look at 4 and 6, but again, we're not going to be able to get a -5 using 4 and 6, so we'll go ahead and drop that pair. All right, so we have our 3 and +3, -8, and now what we're going to do is take our original quadratic here on the left-hand side, these 3 terms, this trinomial on the left, and we're going to rewrite these 3 terms as 4 terms. That's what the AC method tells us to do. Once we've discovered which factors give us what we're looking for, we're going to take these the trinomial on the left and rewrite it into 4 terms. And the way that we do that is we leave the leading term here, the square term. We don't change that, so we have 3x squared unchanged. And now what we're going to do is we're going to split this middle term up, this -5x minus 5x, up into 2 separate terms using the factors that we found earlier. So -5x will now become a +3x and a -8x, so -8x. And then the constant here, -8, was unchanged, and so we'll simply rewrite that. We'll go ahead and include our equals 0, and there we have it. So we went from 3 terms on the left-hand side to 4 terms on the left-hand side. And notice If we were to combine like terms here in the middle, positive 3x minus 8x gets us back to the negative 5x, which is where we started. And so we know that these two equations are equivalent, except here the left-hand side is a trinomial, here the left-hand side is a polynomial of 4 terms. All right, so now that we have 4 terms, you'll recall from class that in order to factor 4 terms, we're going to use what's called the grouping method. And to do that, what we're going to do is break that middle, or rather take that left-hand side, those 4 terms, and split it right down the middle. And what I like to do is isolate that middle sign there. And what that does is it breaks these 4 terms up into a left-hand side, so we have 2 terms on the left, and we have 2 terms on the right-hand side. And now we want to factor the left-hand side here. So we want to ask ourselves, what is the GCF? What's in common between these 2 terms? And taking a look, we can quickly see that 3x is the GCF. And so when we take out the GCF, factor that out, we're left with, well, let's see, 3x times what gives us 3x squared? Well, that would be an x, right? 3x times x gives us 3x squared. And now 3x times what gives us a positive 3x? Well, that's just 1, isn't it? 3x times 1 is 3x. All right, we isolated a minus sign, so that's just going to come down, so we'll bring that minus sign down. And then the process starts all over again. We look at these 2 terms now and ask ourselves, what can we factor out? Well, we can take out an 8, it looks like, right? And if we pull out an 8, again, we're going to ask ourselves, what do we need in order to get back to the original? What's left over once we factor out that 8? Well, negative 8 times what gives us the original minus 8x that we had? Well, negative 8 times just a simple x, right? Negative 8 times x gives us negative 8x. All right, and now negative 8 times what gives us negative 8? Well, that's a plus 1, isn't it? And again, we can go ahead and distribute back through to double check. Negative 8 times x is negative 8x. Negative 8 times positive 1 is negative 8. So that seems to check out. And a kind of a backup to help you is when you're factoring by grouping, what's inside your parentheses has to match. If what's inside your parentheses doesn't match, you've done something wrong, either in your factoring here, or maybe you chose the wrong factors initially when you were using the AC method. So go back and double check. Again, what's inside your parentheses has to match when you factor by grouping. In our case, they do, so we're on the right track. And now what we're going to do is let's pull the factor that's inside the parentheses down. So we'll take this x plus 1, pull it down. And now what are we left with? Well, we're left with a 3x and a minus 8, and so that will become our second factor. And so there we have it. We have the factors x plus 1 and 3x minus 8. And if we were to FOIL these 2 binomials back together, we would end back up where we started with this original trinomial on the left here, 3x squared minus 5x minus 8. But again, we've factored, and now because the directions tell us to use the zero factor property to solve, we're going to set each of these factors independently to 0 and solve, meaning take x plus 1, set it to 0, and then take 3x minus 8, set it to 0, and solve. Well, here on the left, we'll quickly subtract 1, and that leaves us with x equals negative 1. And here we'll go ahead and add 8 to both sides. That'll leave us with 3x equals 8. We'll finish over here. I'll just rewrite that real quick. And if we want x all by itself, we'll divide by 3. And so we end up with x equals 8/3. And so there we have our 2 solutions for number 1. Remember, if we're dealing with a quadratic, we would, in most cases, expect to have 2 solutions at the very most, and indeed we do. X equals negative 1 and x equals 8/3. To check ourselves, if especially on a test we want to check ourselves, what we would do is we would take each of these solutions, plug them in for x, and then solve. So when we take x equals negative 1 and plug it in for x here on the left, when we evaluate the left-hand side, we should expect to get 0. So we want to, after we evaluate, have an equation that says 0 equals 0. And if that happens, well, we know then x equals -1 is correct. And then we want to do the same thing with 8/3. Take that, plug it in, evaluate, and we should expect the left-hand side to be 0. And we would find that that is indeed true. And so our two solutions have then been verified, and we know we're correct. All right, so there was number 1. I will see you at number 2.